Hi, Professor. Hope you're doing fine. And I've come up with an updated version of my code. And sorry for taking this too long. So I'll just get started with it. So firstly, we import the config parser module and we create a configuration file. So here we set various parameters, uh, which we have, that is the bin size, the MLA value, the config ratio, number of tasks, and the maximum execution time. So we use this file so that we could create a .ini file with all the following scheduling parameters. So any changes we make here are going to be updated in the .ini file. Next, we come to this part, which is where we create the random tasks, which is here the periodic task. So firstly, we start a loop to create a config graph which takes in two arguments, that is the number of tasks and the config ratio, which are the number of tasks and the ratio of task conflicts to create the input graph. So this function generates a graph in the form of a dictionary where the keys are the tasks and the values are lists of the tasks representing the conflicts. So the function first checks if the config ratio is equal to 1, and if so, it generates a fully connected graph where each task uh, where each task is in conflict with all other tasks except itself. Otherwise, it generates a random graph with all the specified ratio of conflicts. So this function returns the generated graph. Next, we create the inputs following two arguments, the number of tasks and the maximum execution time, which are the tasks and maximum execution times of each task. So the function generates a list of inputs where each input is a list containing a task ID and its execution time. So the execution times are incremented by 5 for each task, as I have coded it, and the function returns the generated list of outputs. Uh, so the code also imports the config parser module and reads the configuration file at the given path, and it extracts the scheduling parameters from the .ini file, and it generates all the scheduling uh, problems using the graph and the list of task executions. So here is how I've created a loop to create a periodic task with a time interval of 5. Next, coming to the heuristic bin packing algorithm. So firstly, we sort the task list created earlier in descending order by uh, using the time, which is the second element, and assign the results to the sorted list. So it creates a copy of sorted task list and assign it to the uh, other variable, and time underscore here, which is the initial time we've taken it as 0, and BC is the bin count, and the MLA value is taken from the config file, which is basically a string type, to an integer, and then assigns to the variable MLA, and the bin size. This is the main function of the heuristic bin packing. So the function begins by initializing some variables, which are the task underscore sort and the time, uh, which we have initialized to 0, and bin count to 1, and the MLA and the bin size are taken from the configuration file. Then a dictionary and a list of execution order and initialized. So the dictionary keeps track of all the tasks that have been allocated to a bin, and it basically executes the order and keeps track of execution orders of all the tasks. So this function, next we go into the while loop, which runs until all tasks are allocated to a bin. So within this loop, a new bin is created by initializing empty list, which is the L underscore key and L underscore val, and incrementing the bin count, which is B underscore C. So the sorting task, the list is sorted in decreasing order of task duration and assigned to task sort. So for each task, uh, in the task underscore sort, if uh, the task I is already allocated to a bin, the loop continues to the next task. Otherwise, the loop checks if the length of the uh, L underscore key is greater than or equal to the MLA value. So if so, the loop breaks and moves on to the next bin. So if the length of L underscore key is the length of is empty, then the task is assigned to the bin and its duration is added to uh, the time underscore here variable. So we have in basically set it as 0 in the beginning. So this time is added to the time underscore variable. So if the task duration is greater than the bin size, the task is split into smaller subtasks, and the remainder uh, is then set to the task sort term. So any extra time, so basically we have the maximum execution time as 20. So if there is anything extra, it will be saved to the task sort dump and added to the next bin. So the loop checks if the task has any conflicts with the tasks that are already assigned to the bin. So the loop continues to the next task, or else the task is added to the L underscore key variable and its duration is added to the present time. So if the task duration is greater than the bin size, it is split into smaller subtasks, and the remainder is added to the sort underscore dump, as I've said earlier. So finally, uh, so this is the loop where all the extra execution time is added and moved to a new bin. So finally, the tasks assigned to the current bin are added to the execution order, and the function prints the tasks allocated to the current bin, uh, where the execution time for the current bin and the execution order of tasks. The while loop continues until all the tasks are assigned to some bin, and the function returns the execution order of tasks and the total execution time of all tasks. Next, coming to the main file. So here we do all the required imports. So we use the config parser to extract the parameters assigned from the config.ini file, and we create tasks to generate a list of uh, uh, the periodic tasks. And so firstly, the configuration file extracts the required parameters, such as the number of tasks, maximum execution time, and the config ratio. Then it generates a config graph using the generate config uh, the create config graph, and so these tasks, the create tasks have a list of tasks with random execution times, which creates the input function and also creates the also from it takes from the create tasks module. So it calls the heuristic. Finally, this main file calls the heuristic bin packing function, uh, passing in the list of tasks and the uh, config graph. So this function performs the heuristic bin packing algorithm and returns the total execution time and the order of all the tasks. So here we have set as the cycle time, which is required to complete all the tasks using the minimum number of bins. And this all depends on the configuration ratio. So, so as we can make changes here, so I'll put some value of MLA uh, with all these parameters. I'll run this file, and all this will be assigned to the .ini file. And I'll be running the main file as we have imported all the files to the main thing. And so these are the periodic tasks generated with time interval of 5. Uh, so as the conflict ratio is 0, there are no conflicts, and all uh, all the tasks that have the execution time of less than 20 seconds are added to the first bin, but there is task number 5 which has the execution time of 25. But as there is no conflict ratio, even task 5 is added to bin 1, but the 5 seconds are stored to the dump file, and that thing will be added to bin number 2. So the first bin, all the tasks are executed in the first bin, and the additional 5 seconds is added to the second bin. So as we sort the task from the descending order of the execution times. So the order is 5, 4, 3, 2, 1 of all the tasks, and the task will execute in 25 seconds with a usage of 2 bins. And if the config ratio is set to 1 and run this file, so it takes the full time. So here I've printed out which task have conflict with what other. So each task has conflicts with all the other tasks. So for task 1, task 2 until task 5. So these are the periodic tasks generated. So as in the descending order, so we need to execute task 5 first. So it goes to the first bin, and the process moves on, and all the tasks will be executed within 75 seconds. As the conflict ratio is 1 and each task has conflict with all the other tasks, uh, the value of the total execution time will be the addition of all the execution times of all the tasks. So it's 25 plus 20, 15 plus 10 plus 5, which is basically 75. And as the conflict ratio is 1, it uses 6 bins over here. So this is about uh, all the code, professor, and if you need me to make any changes, I'll try my best to do it. And so this is all for now, and I'm happy that you have given a very good opportunity for me, and I promise you that I'll definitely keep it up if given a chance. So, this is all, Professor. Thank you, and I'm looking forward to really working with you. Thank you.